Good. Let's now talk about route tables. In a previous video, we have discussed VPCs and subnets, but we didn't really talk about the specifics of route tables. And route tables are quite important because they define how the traffic is routed within a VPC. So route tables are just sets of rules determining how the network traffic is directed, and the rules are used to determine how the traffic from both subnets and gateways flows. There are both main and custom route tables, and the main route table comes with your VPC and controls the routing for all the subnets that are not associated with a custom route table. So whenever you create a subnet, you can associate that explicitly with a custom route table. If you don't, then the traffic will be routed. It will fall back to the main route table. This comes with every VPC that we create within AWS. As I said, custom route tables are created by us and then also controls the traffic of all the explicitly associated subnets. Subnet can be associated with only one route table. It's very important, but you can share a route table with multiple subnets. So you can have multiple subnets associated with it. Each subnet must be associated with a route table for controlling the traffic for that subnet. Okay, so you have to have an association. If you don't, then the main one is going to be used. The subnet is going to be implicitly associated with this main route table. And each rule in the route table, basically each row in the route table, contains two parts. The destination part, which determines the matching condition for IP address. Whenever we are sending a request to a certain IP address, that IP address is the destination. When a request to an IP address matches the destination, then the traffic will be routed to the target. The target is the second part of our rule, and the target of the traffic matching the destination condition. We'll see some examples a little bit later on, but just imagine that whenever you are sending a request to a certain IP, then the rules in the route table will be evaluated, and then based on the most specific rule or the most specific match, then the target for that request is going to be defined. So the target can be different stuff. It can be within the VPC, can be a local target. It can be through the internet, can be an internet gateway target. It can be to another VPC via a peering connection target. So there can be multiple targets here, and the IP and the rule that matches the destination the most specific is going to then be chosen. The route matching then happens from the most specific to the most general destination IP range. And a local target means that the traffic will be routed internally within the VPC. So this is how a route table looks like. It's very simple, no big deal here. And it's just saying that 10.0.0.0/16 is going to be routed locally. That means if I send a request to 10.0.0.1, for example, then this is going to look for an IP address within our VPC, and it's going to route the request to that IP address. Otherwise, if we send a request to another IP that is not contained in this CIDR block here, then the internet gateway with a certain ID is going to be targeted as a result of this more general rule. Let's have a look at some diagrams, and afterwards we're going to go to the AWS console, because now we have enough knowledge to actually do a little bit of a demo, click around a few places and see how things are going to change based on the configuration that we set up. So we have our region, we have our VPC, and we have two subnets and an EC2 instance in each of the subnets. Now each subnet is associated with its own route table. Here we have created these are custom route tables, and basically they look like this. Very, very simple here. They are the same, and if they are the same here, you could actually have used the same route table for both subnets, but maybe you want to have a subnet that is private, then we wouldn't have this entry here to the internet gateway, right? So here, whenever we send then a request that matches this first IP, this first CIDR block here, what's going to happen is it's going to look into the VPC, and if we send something that does not match the CIDR block, it will be or rather that is more general, right? That does not match that more specific CIDR block. It will be then handled by a router, and in this case this is going to be sent to the internet gateway, because that's what we have specified here in the target for the more general CIDR block. This here with a /0 simply means that everything else, right? So everything here, this is the most general possible match that you can have, which means that all the other rules within our route table will take precedence over the internet gateway one. Now, if we were to come here in our route table and remove this last rule here, this would allow only local traffic, right? So the traffic that would try to go over the router here through the internet gateway to the internet, this would be blocked. This would not be allowed, because there would basically be no matching route here. Whenever we were to send a request to an IP matching the CIDR block, then we would be redirected correctly via the VPC routing. But if we send a request to an IP address that falls outside of the CIDR block, basically we don't know how to route this traffic. All right, so that's it for the diagram part of stuff. Let's jump to the console and let's do a little bit of clicking around and trying stuff around. All right, I'm here in my AWS account as the first screen that you get whenever you create one. If you haven't, I highly recommend you do so. Most of the things that we discuss here are included in that first year of free stuff that AWS gives to us. Some of the things are not, but nonetheless, I think that everything we discuss here would be very, very cheap and worth definitely having your own AWS account to try stuff around. I'm in the North Virginia region here. You could choose whatever is closer to you. To me, that would be the Frankfurt one. But we can work with the North Virginia one. The availability of services depends on the region. So if we were to just have a look at an example here, let's come to the VPC section of AWS. And this will also change based on the region you are in, right? So if we click here on our VPCs, this is the default VPC. This is the CIDR range, the default one that comes with AWS. And if we were to change our region here to Frankfurt, for example, then we will see that this has a different VPC ID, right? So let me zoom in a little bit. And let's go back now to the North Virginia one, and we will see that the VPC ID is different. Another thing is, now let's switch, for example, to the EU West one, and we will see that this carrier gateways here on the left, this is going to disappear as well, right? So here, this is just one example, and I don't know why the zoom here gets reset. That's probably because the prefix here changes, right? So but the carrier gateways here disappears. So depending on the region that you are in, you have different sets of services within AWS, and it may be the case you need to use another region if you're trying to deploy a very specific service that is not available in the region that is closest to you. So let's start by creating our own VPC. This is the default VPC. If we just click a little bit around, we will see that we have a main route table here, right? This we have talked about it. And we also have a few subnets. We can scroll down, you see that we have 6 subnets, as discussed already in another video. Each VPC comes with a default subnet per availability zone within AWS, and they're all associated with our route table here. If we click on the route tables, we will see just one of them, and that is the main route table. You can see here that we can actually set which one is our main route table. So even if we create a custom one, we can later on set it as the main route table so that it's the default, it's the fallback route table for subnets that do not have a custom, a specific, or rather an explicitly associated route table. So let's stay outside of our main VPC here. And let's create another VPC, and we'll simply say demo VPC. And this here will just give a CIDR range of 10.0.0.0/16, right? So this is a very broad range here. We could be a little bit more, I don't know, a little bit more strict, maybe 20, but we can keep at 16. No CIDR block for now. Tags, we're just gonna call this demo VPC, and we will just click on create VPC. And then we have our own VPC here, and if we click under route tables, we see that we have a new VPC and a new route table, and this route table here is then the main route table for our new VPC. So now under our subnets, let's have a look here. We have 6 subnets. These are all for our default VPC. So let's create 2 new subnets. I'm not going to entertain the thought here of creating 6 subnets manually. So let's just make a demo subnet 1. Availability zone, just going to put 1A, and the CIDR block here is just going to be 10.0.0/24. And the name is going to be demo subnet 1. Let's create it. And the moment we create here and we click on the subnet, then we have a bunch of information here. See, the route table is this one, and that is the main route table because we have not defined. So if we click here, right, and we click here, then we'll see that this is the main route table for our demo VPC. One very interesting thing, if I were to just come here on the route tables and compare them, this is the route table, or maybe I could go to the previous screen here. So if I click here and then I click on the routes, right, we can see here the routes that are within our route table. So let's select the one that comes with the default VPC. That's the one at the bottom here. We can see that there is a demo VPC here on the left or on the right of our VPC, so we can differentiate them. And the routes for the default route table, they include a catch-all CIDR block here that is going to direct traffic to an internet gateway that is already shipped for us. This is not the case whenever we create a new VPC, a custom VPC. We do not get an entry redirecting traffic to the internet. That means that this VPC here is not reachable and it cannot reach the internet by default. If we were to want this to happen, we have to add our own entry to an internet gateway. Good, so we have here our subnets and we have a few. So we can differentiate here by the name. We could also filter them by the VPC. So if we want to click here VPC, and I don't remember which one, I think it's this one. Yeah, perfect. So now we can create another subnet here also inside the demo VPC, and we'll say demo subnet 2, and the availability zone is going to be 1B here. And just for the sake of demonstration, let's see what would happen if we were to try to create an overlapping CIDR block. If we were to try to do something like this, we see that we get an error and it says that the CIDR address overlaps with another subnet, right? So one way of doing that is let's flip here the first bit of this range. So that because we are fixing only this part here, then whenever we change this, we can ensure that this is not overlapping. Let's create this. And now if we come back to our subnets and we add a filter to the VPC that we have also created, then we have 2 different subnets. Great, so that's the first thing here. We have now subnets, we have route tables, that's great. Let's now launch an instance, an EC2 instance within this subnet. So I'm just gonna come to the EC2 instance here, that's the EC2 instance dashboard. And here, if we look into the running instances, then we will see that there is nothing. So let's launch a new instance and let's tag this demo, or rather, let's say EC2 subnet 1. We're just going to run an Amazon Linux, no problem. Instance type, we'll keep the free one here, the T2 micro. Let's create a new key pair so that we can SSH into this instance, and we'll say EC2 subnet 1. That's great. We're going to create this. This is going to download this key pair for us here. So we're going to close this now. Network settings, right? So network settings, this is where we can set where we want to launch our EC2 instance. The default VPC is most likely going to be selected for you. Let's switch to our demo VPC, and then we can choose between the 2 subnets that we have. We will also auto assign a public IP here so that we can SSH into the instance. We'll create a security group, and this security group is going to be used for all the instances that we will launch today. So we're just going to say demo SG. Right, so here now we can say demo SG as well, so demo security group, and we are going to add a rule that's going to allow basically SSH traffic in port 22. That is probably not the thing that we want to do in production. We don't really want to open the port for SSH because that could introduce attack vectors. But here, for demonstration purposes, let's just keep things simple. All right, so nothing else that we need to change, just important that we auto assign a public IP so that we can SSH into the instance. Now that we launch this, we could then wait here. We can actually create another one, and let's launch another instance here inside of the subnet number 2. So let's say EC2 subnet 2, and again, Amazon Linux, everything is the same, yada yada yada. Let's create a new key pair, EC2 subnet 2, create key pair. And then here within our network settings, we will deploy this inside of the demo VPC and demo subnet number 2. And we want to enable the auto assign of public IPs, right? So here we will actually select an existing security group, and this is going to be the demo security group. Now the security groups, it really provides a set of rules to prevent, or rather to control access to a certain instance. Yeah, so here, basically, whatever security group is attached, this set of rules is going to be applied to the traffic incoming and outgoing from the instance. We're not going to go to the details of security groups today. We can talk about it in a later video. But the bottom line is that by having the same security group, this does not automatically allow instances to talk to each other. Okay, like security group is really just a set of rules that checks for and controls the access towards our instance and from our instance towards the outside world. It doesn't automatically allow communication between instances that have the same security group. That's just a small remark for you to keep in mind, because this can be a common source of problems in communication, in networking. So everything looks good to me. Let's also launch this instance here, and let's see whether we can actually SSH into these instances. One of them is already running. So if we were to actually click here and click on connect, and then we could come here to the SSH client and see whether that is going to work for us. So I'm here in the terminal, and here if I just give an ls command, I have moved the 2 files to this folder here, so we can use them without problems. Back to the browser, let's have a look. This is quite straightforward to follow. So we have locate your private key file. That's our PEM file here. And then it just makes sure that we have a little bit less permissions, right? So change the permissions to the file here, and then we can issue this command here in the console. As you might guess, this is not going to work, right? Because we have already discussed that public connectivity is not enabled by our custom route table, and that makes sense. So this is just going to time out because we have no way of actually reaching this instance here with this public IP address. So if we come back to the AWS console, we click on the instances here. Now both of them are running, which is great. And then we click here on our subnet ID. We can come here and we can then come inside of subnet, and then we have our route table, and we will see that we have within here basically no entry to the public internet, right? So nothing is coming in. How do we solve that problem? Well, we can create a new internet gateway. Let's create an internet gateway, and we'll say just demo IGW, and that's it. That's all we have to do. We create a demo internet gateway, and then here within our route tables, we can then edit this route table here, which is the route table that is the main route table for our custom VPC, right? And if we click here and under the subnet associations, we will see that there are no explicit subnet associations, but because there are 2 subnets without these explicit associations, then they are indirectly they are indirectly associated with this route table. So routes, let's edit the routes. we already know what we want to do. We want to allow traffic from everywhere, and we want to direct this to an internet gateway, and there is nothing here because we have to attach the internet gateway to the VPC, right? So we have created the internet gateway. That's nice, that's all good, but if we look here, it is detached. So basically we come here, and if we want to edit it, we can click on Actions, Attach to VPC, and then we can select our demo VPC, and we can click on Attach Gateway. Now the state is attached here, and then under our route tables, we can just come here, click here, edit the routes, and then we can finally add it here. It took a little bit of time, and as you can see, there are lots of things we have to create and lots of things we have to move around. So the moment you select Internet Gateway here, then this will give you the suggestion of the internet gateway attached to this VPC. Now, if I just remove this, you can see all the possible targets that this can come in, or that can be set here in our route table target column, right? So we have internet gateway, net gateway, we have peering connection, and this would be used if you have a VPC peering connection to another VPC, and then you would have, maybe let's say that we would like to make a peering connection to the default VPC 172.31.0.0/16, and then we would here create or point to a peering connection. Nothing is created here, right? No, we're not gonna set this up now, but that's just a little demo. So let's redirect all the traffic here to internet gateway, to the internet gateway that we have attached. I'm gonna save the changes here, and the moment we do these changes, when I come back to the terminal and I try to SSH again, then boom, that works, no problem. I'll say yes, and then here we are actually inside of our Amazon Linux EC2 instance. That's perfect, right? So the next question is whether we have connectivity from within this instance here to the outside world. And yes, we do. If we were to just ping google.com, then we're going to start getting some answers back. That's great. And you see here there is a little bit of information from the ping command. If we were to also send a ping to a specific IP address, so let's say www.google.com, that should give us the IP address, and that's this one, I believe, right? So maybe we could try to ping this address here directly, ping like so, no problem. We start getting the result as well, right? So now here, let's try to talk to actually our other EC2 instance. So we have our instances here, and we are connected inside of the subnet 1 instance, but let's try to talk to the subnet 2. We have a public IP address, so maybe I could actually try to ping the public IP address. And the moment I do that, oh, that doesn't really work. And that's no connectivity issue here. This is a restriction at the security group level. So let's just fix that. And here we can come to the security groups, and then under security groups, we can choose the one that we are using. That's this one. You can see that we have two default security groups. These are security groups that are shipped by the VPCs we create. They come default security groups to the VPCs, right? So the one we want to edit here is the demo security group. And then here, if you look at inbound rules, then you see that we have basically no rule here that allows this little thing here, ICMP. This is the ICMP traffic run by ping. So if we were to edit the inbound rules and add a rule here, and we will say all ICMP, you see that's what we need here. We're going to allow everything, and the source is going to be from anywhere. We save the rules. This is done. This applies then to both our EC2 instances. That means if we were to try to ping it here, then boom, that's already working. No problem. Now we can actually send the ping command to our EC2 instance, to the other one that we have deployed, and this is working just fine. Now, last thing for today, I know it's a lot of stuff and a lot of numbers, but I find this fascinating, so that's why I really like to spend time here. And great, so we have talked via the public IP address. Anyone can talk via the public IP address, right? If we were to come here and create a new tab here, let me just zoom in a little bit. Oh, that's not gonna work. So maybe I can try to split this. Okay, got it, finally. I'm not inside of our EC2 instance in AWS, I'm just in my computer, and if we were to try to ping here, and that's not the right one, right? So this is, let's get this IP. We'll try to ping this IP, then we will get some responses. Okay, so it's no problem because this is a public IP, and now we allow the traffic via our security group. That's great, that's working. But what if we want to actually use the private IP address? And you see here that this private IP address is different than the public IP address, right? So this private IP address here is valid only within the VPC. If we were to try to ping this here, that is not going to work. Okay, it's just not going to work. It's gonna time out because look, it's basically cannot solve this address here. But if we were to actually run a ping command from within our EC2 instance, it solves it without a problem. It finds the EC2 instance because this here matches the more strict rule in our route table. So back to the route table. Where is that route table? Here. All right, so we can see here that this matches this more specific rule. And as we already discussed, this more specific rule here takes precedence over the more general one. All right, so that's it for the demo. Let's just destroy everything that we have created here, and to make sure, right, that we don't get any bad costs at the end of the month. So instance state, let's just terminate everything. Yep, you can terminate everything. Then let's come to VPC. And remember, we have created VPCs, internet gateways, subnets, and route tables. So we'll just come here, let's delete this. Probably we need to detach first, right? So we detach this, and the moment we detach it, we say that we cannot do that because it has some mapped public addresses. This means that this is mapped in our route table. So let's first of all remove the entry from our route table, edit routes. Let's remove this, save the changes, perfect, internet gateways. And now we can come here, and probably now everything would be fine. Let's detach. Yes, everything is working, no problem. Clicking here, deleting the internet gateway, we need to type delete. And then now here within our subnets, we could delete directly the subnets here, but actually we can just delete everything, right? So let's just delete the demo VPC. And the moment we do that, AWS will inform us, okay, look, I'm going to also delete a couple of resources that I have created for you, right? So once we create this, once we click on delete there, it deletes everything. We have a look at route tables. Route table is also gone. There is one thing, perhaps it's still there, and I believe that is the security group, right? So if we come here, security groups, no, that's also gone. That's perfect. Okay, great. So that, as you can see here, the key pairs are still here. Probably, yeah, the key pairs are still here. So maybe we can also delete these key pairs here. And that will also work, right? So that's it for the basics, really the basics of route tables and routing within a VPC and how to send traffic to the internet. Just very good that we are aware of it, very good that we know how it works. Probably in a real world project you would not, and hopefully you wouldn't create stuff manually. You would use a tool like Terraform for infrastructure as code, or CloudFormation in AWS in this case here. And if you don't want to miss the discussions I'll publish on the topic, then make sure to subscribe to the channel, and also leave your comments, leave your feedback in the comments below. Thanks for staying until the end, and I'm looking forward to seeing you in the next video. Have a good one. Bye bye.